TypeScript is an awesome tool that when you dive a bit deeper into it can have some really cool and advanced tricks. Today I want to explore map types, template literal types, key remapping, conditional types, and more. And I'm going to do this all by setting us up with a challenge. So the challenge here is, given this interface of person with name, age, and location, can we create a generic type that's going to return us this person getters, so something that looks like this. So what we're going to have to do is prefix get on the front of all of these, capitalize that N or the A or the L in the name to capitalize the first letter, and make the return type instead be a function which returns the original type that it was. To get started with this, we're obviously going to need to define our generic here. So that's going to be type getters, and then here we're just going to put type, and then we're going to equal that to the type at the moment. So this is generic here. So what we're doing is we're going to be able to pass through a type to this. So now if I just set up the solution, which is going to equal to getters and then type here, this way we'll be able to see when we pass through person here that at the moment solution is returning person. The reason I've set this up here though is just so we can see what we've got as we're working on it. So there we go. So how do we start with this? To start, we're going to need a mapped type. Now, what a map type is it's essentially a way that we can iterate over the keys or the properties of another type. So we'll be able to iterate over name, age, and location here. To get started with a map type, all we need to do is come into this type here. And then within this, we're going to use square brackets. And then what we're going to say is property, and then in, and then key off, and then the type that we've passed through, so the generic we've passed through there. So what this is doing is property here now represents each one of our keys. And the key off, essentially this bit here with key off type, this essentially creates a union of all of the keys on this. So it's essentially key off type is going to equal name, age, or location here. And then lastly, what we're going to do here is we're going to set the type that these are going to be. And here what I'm going to do is I'm going to come in and simply say this is going to equal to type and then property. Now all this is doing is indexing again to find the original type. So as I said, property here could be name, age, or location, and then we're referring back to that generic type that we passed in to get what that string or number would be for the property within that type. And essentially what we've got down here with solution is what we had before. So it's not quite complete yet because we need to use a couple of other tricks. So the other tricks we need to do is we need to make it prefix get and then capitalize the first letter here. And we also need to change this type to a function. So what we can do is we can instead come in here, and changing the type's really simple. As I said, what we've done here is we've essentially remapped the type anyway. And all we need to do is come in here and change this to equal these types here. So it's going to be a function. And then as I said, type property here is going to be able to refer to our original types up here. So if I now hover over solution, what you'll see is that we've essentially got that second part done. So our solution here now has name is equal to a function, which with a return type of string, and age, and so on. So the final bit that we need to do is we need to utilize our template remapping and our key remapping to get name and capitalize the first letter here. So how do we do that? Well, the first thing we're going to want to do is you need to come in here, and where we have as key off in type, what we need to do is we need to change this slightly. So we need to come in here and say as, and then in here we're going to do type or property, and then in here we're going to put our template literal. So what we've got is type as, and then within here we're going to do get, and then we're going to use our expression here to return string, or just let's return the property. So when we hover over solution here, you'll see that we've got a part of that done now. So what this has done is it said property and key of type, but now treat it as this. So we're remapping this here. So we're remapping what the original key or property is here. So what we've got is the property and key. So this could be name, as I said, this could be age or location, but now treat it as, and then we've used a template literal to put in the original property, so name, age, or location, but we've appended get to it. And as you'll see with the solution here, this comes out as get name, get age, get location. So we're close. It's not quite perfect as we need to capitalize now. And the other thing is we've got an error here that says this isn't assignable to the type string or number. To fix this, what we need to do is do string and. Now what this is doing is just telling TypeScript here to treat property always as a string, as that's what it's going to be. So you'll see that that error's disappeared. But now to capitalize, we can use a built-in TypeScript feature of capitalize, and we simply just wrap that around that string and property there. And there we go. we've used key remapping there, we've used map types, and we've used this template literal here. And that has got us the solution. So here you can see we've now got get name and get age and get location. So we can now use this getters type in anything. We could change this to get email, for example. We could change person to email here. And down here, this now has get email in it. So you can see this is a powerful way that we could write a generic to wrap around some things here. So as I said, there's a little recap here. What we've done here is the mapped type. So property in key of type. So this is essentially saying name, age, and location. And then we've said, now treat this instead as, and then we've used that template literal to make a new string essentially of what we want the new property name to be on that type. And finally, we've just assigned that type to a function that returns the original type here by going back and indexing that using the property that we had here. The next challenge that I want to show you is another really cool one that's going to use some similar things that we've used here, but we're actually going to use template literal inference as well. So for challenge 2 here, what I have is I have a type of people, and I'm just using that person interface that we had before. But essentially each one of these people, so subscribe James, is assigned the type person. But then we have Chris and Timmy down here. Now they're not subscribed to me, so they're going to be missing out on the latest web development tips. So I highly recommend you subscribe so that you don't end up on this list with them. But what we want from this is we essentially want to make this type return only the people that are subscribed. So if we come here and we use our generic, what we can do is to do type and then only subscribed. And then as I said before, we're using that generic here of type. And for now, as we did with the last one, I'm just going to return type. And for the solution, that's going to be a list of cool people, obviously, because they're subscribed to Jolly Coding. And that's simply going to equal to only subscribed and then people. So as I said, as we have before, what I need is I'm going to work on this as we go. But for now, cool people is obviously just equaling to that people. And that's going to have Chris, Timmy, and everyone on it. But we need to filter this out. So how do we do that? Well, the first thing that we need to do is we need to come in here and we need to utilize that key remapping, or mapped types as we did before. So we come in here and again, we do property in key off and then type. And then for now, we will return the original type as we're not actually going to be modifying that. So again, what we do is we do type and then we access that with property. So we're just going to get the original type of that key. For this one, we don't really need to bother with this bit because that's what we want back. So as you'll see, this list now of cool people still has Chris and Timmy in it. And we need to get rid of them by finding out who is subscribed or not. So how do we do that? Well, what we need to utilize is a key remapping here, like we did before. So we need to come in here and do as, and then we're going to say property. But then what we want to do here is also use a conditional type. Now, this is where this starts to get a bit complex, but essentially what we need to do is say if property extends. So here we're going to say if property extends, and then this is where we use template literal inference. So what we're going to do here is we're going to type subscribed underscore. And then in our expression here, you can do something really cool with TypeScript. If we do infer, and then I'm just going to leave this as underscore, you could set this to anything you want. As I'm not using it later, I'm comfortable with leaving it with underscore. If you were going to use this inferred bit later, you might want to use something else for its name. But I'm going to do property extends subscribed and then underscore. Now what we're saying here is this is essentially saying if property extends subscribed, so it's going to look through all of these strings and see if it can find that subscribed bit. And then infer underscore is going to equal the bit that isn't them. So what we're doing here is we're going to match that, but now we need to use our conditional. This is where we then use that conditional type. So we put a question mark here. And now with that question mark, so what we're saying is, so yes, if property has subscribed underscore on it, what do we want to return? Well, we actually just want to return the property if that's true. However, if that's false, what you're going to do is you're going to use never. Now, never is essentially just going to delete it from the type now as it's never going to exist. So now, hopefully, using all of those tricks, what we've got is a list of cool people. And yes, we have so only the people who are subscribed. So here, as you can see, we've taken that initial list and Chris and Timmy have been taken off of it. As I said, if we went and deleted some of this, what you'd see is we'd actually get a list of the same people there because it's going to find that subscribe in it. If I got rid of this and put not or something like that, you would see that we'd get an empty list as it's not going to be able to find anyone with this prefix on it. So this is a really powerful feature of TypeScript template literal inference of how we can extract stuff from strings using TypeScript. Just to recap this one, as this one was a little bit complex, what we've got here, as I said, is we've got this mapped type. So we're getting for each property in key of type. So for each subscribe James, subscribe Kate, all of those, we're going to get them, but then we're going to key remap these to say as, and then this bit here is the key remapping. So what we're doing, we're saying as, but then we're saying, so if property here extends subscribed, then just return property. So we've taken subscribe James, it would say, yes, I found subscribe on the front of that. So then it's just going to leave it as subscribe James. However, if it can't find that, so this expression here is false, it's going to set it to never, which is going to get rid of it on that type there. And as I said, that's where we get this list of cool people. Now, hopefully that wasn't too confusing and you learned some really powerful TypeScript tricks here. If you have any more questions about this, please leave a comment down below. And as always, thank you for watching.